So why 6.02 times 10 to the 23rd? Why not just 1 times 10 to the 23rd? We saw why it has to be such a big number. Because molecules are so small, you have to have a lot of molecules in order to actually measure them with a unit that makes sense. So 18 grams of water, which is the same as 18 milliliters of water, is 1 mole. So we need that many molecules to have something measurable. But why 602 sextillion? Well, the reason for that is actually a really neat trick that scientists figure out when they develop the mole. That number, Avogadro's number, was picked because the average atomic mass for an element, as shown on the periodic table, when converted to grams, is equal to the mass of 1 mole of that element. And this number is known as the molar mass. And because we always care about our units, the unit for molar mass is grams per mole. And yes, mole is abbreviated MOL. We just drop off the E. So what does this exactly mean? Well, let's say I wanted to know the mass of 1 mole of helium. So we look at the periodic table, and we see that the average atomic mass of helium is 4.002602. And that's in AMU. But if we change that to grams, I get 4.002 grams per mole. And this is the mass of 1 mole of helium. So if I had 4.002 grams of helium, I know that I have 6.02 times 10 to the 23rd atoms of helium. Let's do another one. How about copper? What is the molar mass of copper? And these again are called molar masses. What is the molar mass of copper? Well, copper has an average atomic mass of 63.5 AMU. We convert that to grams, and we get 63.5 grams per mole. So if I had 6.02 times 10 to the 23rd atoms of copper, I would have 63 grams of copper. Well, why are these so different? Both of these represent the same number of particles. Both of these are 6.02 times 10 to the 23rd atoms for each element. So they represent the same number of particles, same number of atoms. Why are they so different? Well, the size of the atom is very different. Helium has an atomic number of 2. It has 2 protons and 2 neutrons normally. Copper has an atomic number of 29. It has 29 protons and 34 neutrons. It's a much bigger atom. It's the same thing as when I was comparing bowling balls and golf balls. If I had, let's say, a dozen bowling balls and a dozen golf balls, I have the same number of each, but the bowling balls would weigh much more than the golf balls. So the mole works the same way. Heavier atoms will have a higher molar mass than the helium atoms, which are much smaller. Now think back to when I was talking about how many particles are in a mole. What exactly do I mean by particle? in the examples I gave on the previous page, I said that the particles of those elements were atoms. So in 1 mole of an element, I have 6.02 times 10 to the 23rd atoms. But when I was talking about water, I said I had a mole of water molecules, 6.02 times 10 to the 23rd water molecules. So a particle could be atoms or it can be molecules, just depending on what I'm talking about. And we saw that in order to find the molar mass of an atom, we would look at the periodic table, and the molar mass, the mass of 1 mole of that compound, is equal to the average atomic mass when you change the unit to grams. But what if I have a compound? Let's start with, let's say, carbon monoxide, CO. What is the molar mass of carbon monoxide? Well, we know that carbon has a molar mass of 12.01 grams per mole, and we know that oxygen has a molar mass of 16 grams per mole. So what we're going to do is add those together, and we'll get 28 grams per mole for the compound. So all we did was add the molar masses of each element. Well, what if we have more than one of an element in a compound? For example, water, H2O. Well, we know that hydrogen has a molar mass of 1.01, but we have to multiply that by 2. We have 2 hydrogens here, so we're going to write times 2, and that equals 2.02 grams for hydrogen. And then oxygen, we know oxygen has a molar mass of 16. We add those together and we get a molar mass for water of 18.02 grams per mole. So now we know the mass of water that contains 6.02 times 10 to the 23rd particles. All we do is add up all of the elements that are in our compound.